My name is JJ Asghar, and I'm a developer advocate for IBM Cloud. Today I'll be talking about how we accidentally created a cloud on top of the IBM Cloud. Hopefully you'll learn some things about what we did wrong and where we came from and what we ended up, and maybe a couple laughs along the way. So let's get started. All right, hopefully you can see IBM here, which is perfect, and let's keep going. So as I said, my talk today is called We Accidentally Created a Cloud on Our IBM Cloud. Hi, again, I'm JJ Asghar, developer advocate for IBM Cloud. You can find me at JJ Asghar on Twitter, and also, yes, really awesome at IBM.com. So, that's it in a nutshell. So your first statement is probably, wait, what's going on here? Why is this a talk? Why is JJ telling a story of creating a cloud on top of a cloud? It seems kind of weird. And it turns out this is actually a really good microcosm of the story of iterations and lessons learned about moving from a simple situation to a much more complex project that is, especially as an old sysadmin or SRE or DevOps engineer, whatever you want to call me. This was a really good narrative on how these things kind of happen over time. So hopefully you'll learn some stuff from what I've done, or what our team has done, and you can kind of bootstrap yourself to get to the next step. So let's keep going. So the whole core of this was basically this one specific problem, which is before the COVID times, when conferences were still around, we developer advocates for IBM would go to conferences and run workshops. We were one of the first clouds out there with one of the newer releases of Kubernetes, and we really like to tout and show that we were on the cutting edge. This also required us to spin up Kubernetes clusters anywhere ranging from 30 to sometimes hundreds of Kubernetes clusters. And we needed also the newest versions of doing it, or newest ways of doing it. So we had to spin up all of these clusters and use the normal IBM CLI or the IBM console. And it was very, very, what's a good word for it? Slow. It was very, very slow, and it was very painful. So we started finding out that, to spin up one cluster would take X amount of time. And then if I had to spin up 30 of them, it was really hard to do it in parallel, and it was just inefficient. So we had to start putting some engineering time around it. And we discovered that, yes, as I said a moment ago, the IBM CLI existed, and we started iterating on that. So the iterations kind of went from the very beginning to what we have now. And I'm going to walk through a couple of the iterations to just kind of explain why initially clicking around in the console to where we are today was bad. The first thing we ever did was, just because I'm an old sysadmin, of course we played around with Bash. Bash was just basically a massive for loop where we requested a bunch of Kubernetes clusters from IBM Cloud, which in essence, I mean, if you only have to do this once or twice, that seems pretty good. You just be like, hey, give me 30 clusters, spin it up inside of this account, and, call it a day. But as we started getting more and more conferences, we started hitting the API more and more, and I would spin up 30 clusters, 40 clusters, sometimes 70 clusters, and then I have to spread it across all our zones and all. And I'll talk about that here in a moment. But the challenge is to be able to keep all these up and running, because, I might have a conference in the US on the East Coast for 3 days, and then I turn around and I have another conference in EMEA that are across only 2 of those days, so I can't reuse this hardware. So I'd have to continually iterate around it. Especially now today in the post-COVID world, or COVID world that we live in now, workshops are even more important. So I even have even more clusters going on. So what we had originally was not going to work. But the first script I'm going to show you is this verify script. And as you see, it really is truly just a for loop. If you take let me turn on my little laser pointer here. If you see here, it really is just a for loop around something called zones. Now, I'm showing this one off first because it turns out inside of IBM Cloud, we have no way to dynamically create our VLANs. So as you see here, we have a public and a private VLAN that you attach your clusters to. So over time, specifically, one of the technical challenges we had was we have all these VLANs in all the different zones, and we have, upwards to 40, 50 zones now. And I'd have to have these public and private zones already created. So every night, I would actually run this verify script against every single zone to make sure that the public-private zones already existed and didn't have to be created beforehand. I learned over time that I actually really, really annoyed our SREs on the IBM Cloud side because they would see, 50 or 60 clusters spin up overnight. And as you notice, they're really small clusters that don't do anything, sit there and then get destroyed the morning before because I have another Jenkins job that goes around and cleans all this stuff up, which, is just wasting resources. But it was a limitation that we had to have. And it was just weird, right? But this is, in essence, the first iteration of creating a cloud, right? Where you just run a bash script against the API, which in this case is the IBM Cloud here. And then you just verify what's going on. As you can see, it doesn't work anymore. And there's been some progressions here, but it's still important to see. Because if you actually look at the actual script that I used to do to run and to spin up all the clusters, it was in essence just a for loop that would spin everything up in the background on my laptop and just, shotgun out a bunch of different requests. I do say though, as you notice here, I do have this sleep random 30 because turns out I overran the API a few times on the IBM Cloud, actually causing a real outage. So I ended up learning to put a sleep there. So randomly for 30 seconds, instead of me like shoving, 75, 100 clusters all at the exact same time, I would split it out over 30 seconds, which seemed to have worked. But if you've noticed here, this is all just spinning up the VLANs and the different version, Kubernetes version, which was pretty great. But there's this whole other section here where there's this curl. And this is important to say because the IBM Cloud, turns out we have a tagging mechanism, but it's a separate API. So we end up having to create another curl against it where we'd have to sit there and wait for the backend to acknowledge that the cluster created. And that's what this waiting for about a minute is. And then it would send, hey, the CRN, go ahead and tag against what the tag is for the account for the ticket. And as you can see, this is really convoluted and it became so complex. And I ripped out a bunch of different things here that this is just more than we needed to do. It was only a handful of people here inside of my little team who understood what was really going on. And that was really challenging. Granted, we're all sysadmins at heart, or at least in this time we were, but this is not something that we could bring in more people. And the reason why I bring this up is because the natural progression was we started to grow our team because we had so many of these workshops and so many of these conferences and so many, especially now that we're doing everything remotely, started coming together that we needed to offload of this work. So it wasn't just me, a sysadmin, and my manager anymore. Now it was me, a sysadmin, and we even had 2 developers giving me about 15 to 20% of their time. We started looking into the Python SDK because we were like, hey, there's got to be a better way to do this instead of a bunch of bash commands. Well, the challenge is that none of us actually knew Python, right? Like none of us were Python developers by any standard. Yes, we could read it and understand it, but it's not how we thought. We had a Node developer, we had 2 sysadmins who just wanted to do everything in bash, and I had a Go developer working with me. So we started looking deeper into the Python SDK, mainly making it an excuse to start learning more about Python. And at IBM, Python is the language that is defaulted that most people use because of all the ML work and things we do. But it turns out that this Python SDK at the time wasn't as robust as we thought it was. And we also had to relearn how to do a lot of stuff. So we ended up moving past this. But it was at least nice to know that this existed. And it's important to bring back in a moment. The next natural progression we moved into was using Ansible in the community plugin. Now, this is around the time that we were closing our deal with Red Hat. So needless to say, we were like, well, if we bought this company called Red Hat, we should probably use their software. So Ansible was the go-to for at the time. But as we started plugging around inside the Ansible community plugin, we discovered that there's just some oddities in it. And it didn't seem like it was actually being like written by a human. There was a lot of really, really like programmatic code inside of it. And we ended up finding what we call internally at IBM offering managers, but in the rest of the world, you call them product managers. And ask like, hey, what's the deal? This doesn't seem like it does what we expect it to. And they're like, yeah, that's the way it's designed, because it turns out, of course, Terraform still is around. And it turns out the team was actually focusing on building higher Terraform support and then shoving that Terraform code through some like Rosetta Stone that turned it into Python and Ansible, which needless to say was a little weird. So needless to say, as soon as we heard that, Terraform was the quote unquote higher supported version, we decided to spend some time with it to kind of answer the story. Now, as you heard, there's about 4 or 5 people now, including myself, that had to kind of keep this stuff in order and kind of understand where the different lines were. And Terraform and the state files between a few people, unless you go into like something like Terraform Enterprise, is a little bit challenging. We had problems just learning how to store the state files between different machines or different people. And then also the challenge of knowing how to like edit the Terraform plans to get to what we need to do weren't great. We had some variables and we created some wrapper scripts. Hell, I even started learning some Go templating so I could templatize out the plan by pulling in that local.env file that you saw at the very beginning or very top of that earlier script. So everyone could at least have the same workflow. It would just kind of dump it out. But it wasn't great. And also, if you notice, the Terraform moves relatively quickly, and we had some breaking changes that we just kept finding over and over again that it just wasn't worth, trying to keep it alive because it wasn't consistent. And it was weird, and it didn't do exactly what we wanted to. So we actually walked back to Ansible. So after Terraform kind of not fitting how we really wanted to do the work, and the initial Terraform plan or the initial community project for Ansible didn't really fit how we wanted to either, we actually spent some time and really looked at how Ansible did its job and then tried to come up with a way to kind of fit that workflow in, because we started realizing we need to do post-provisioning. I've completely skipped over this point, which is after you build a bunch of clusters, occasionally you're going to need to do post-provisioning on it, like install specific middleware or whatever. Maybe you need to do an Istio workshop, or you need to do, like a Jenkins or a Argo CD workshop on top of it. And sitting there and running a bash script with a bunch of kubectl commands inside of it is janky, to say the least. So we started we took a step back and started looking at a way to orchestrate being able to spin up a bunch of clusters, and then after the clusters are done, do some post-provisioning against it. And that's where Ansible came in. It turns out was really, really strong for what we were doing, because we fire and forget requesting a cluster, which could take X amount of time. And then with X amount of time, when it comes up, then Ansible can go into some other tasks and install stuff for us. That's where we discovered something called AWX. Now, this is kind of the core engine that we ended up sticking with and have stuck with, which if you didn't know, AWX is the upstream open source version of Ansible Tower. And it has this beautiful interface. It has this beautiful interface and beautiful API that you can just shove Ansible playbooks at it, and it can just start doing the work for you. But obviously we need to have a bunch of different workshops running at all different times with different tags and different entry points. So we needed a way to programmatically manipulate AWX to do all this work for us. And that's when Mofi, who's my Go developer, created a project called kubeadmin. And I'll show that here in a moment because the whole goal of this is for me to show some of this stuff off. And hopefully you can see how the advantage of moving from a bash script to something like an actual application can start making your life significantly better. So let's actually take a quick moment and look at some of the code, and hopefully this will show how I want it to. Here we go. So this is actually kubeadmin right here. As you can see, this is IBM Cloud, create and schedule. And if you look, if I go into the, like, for instance, my workshop account, which is if you've ever taken an IBM Cloud workshop, you might notice that number before from us. But as you see here, there's a bunch of clusters already being spun up and ready to go. And I have the ability to basically find all the ones, for instance, in this like Fonty's lab. I can type lab and then just click a button and then click delete. Now, believe it or not, that is literally 14 different clicks. That's not hyperbole. I think it is actually 14 different clicks to be able to actually get Kubernetes to delete stuff, or for IBM Cloud to delete stuff for you. So imagine doing this over and over and over again. And that's just deleting. Inside of creating, if I come back over here for a second, make this smaller. If I go to cloud.ibm.com, and if I decide to want to create a bunch of resources, I actually have to create this resource, go through a catalog system to be able to request what I need. Yes, I can come over to this, Kubernetes overview and create a cluster, but I still have a bunch of things to fill out and do. Where with what Mofi had created, leveraging the actual application, we were able to start being able to just fill out the information, and then it would do a for loop against it, or a for loop with a bunch of things underneath AWX, which saved so much time and effort. And the reason why I want to bring this up and show this is because the ultimate goal, which I'll show here in a moment, makes things happen. If you take one step farther, here's actually AWX right now. If I go ahead and grab the password, AWX, copy, admin password. As you see, it's just an interface to play a bunch of templates and jobs off of it. And as you can see, like I created a bunch of clusters yesterday, which is, yes, yesterday. And, I had 73 fail, but that's actually failing because, timeouts or whatever. And they retry. We have retry logic inside of it, which is great. So now instead of having this bash script that just shoves a bunch of requests at it and overruns the API, leveraging the system we have now, we actually try, fail, okay, wait for 15, 20 seconds or whatever, and then try again. So instead of just a simple bash script overrunning everything, now we actually have real logic inside of here. If you want to take a look here, this is the actual collection that Mofi created, which was, as you see, it's literally just what we need to do. One of the advantages of being able to rewrite this for specifically our needs and not using the upstream Ansible / terraform converted Ansible thing was Mofi was able to write specifically what we needed and nothing more. The other cloud API, the IBM Cloud upstream had all these other options, that all these other knobs and bells and whistles that just weren't what we needed. So we ended up just stripping out exactly what we need. And then as you see, it literally just runs run module, which is right here, puts in a bunch of args, and then just shoves it into the API, which in essence, that's literally it. It's just right here. That's the core of it, which is pretty great. So we were able to wrap this up inside of AWX and then be able to actually do real post-provisioning afterwards. If you take the next step, and after you're looking at that, if you're ever curious, and if you do use IBM Cloud, our little admin page here, all this stuff, which if you ever do need to control multiple clusters or multiple resources is actually another open source project right here. I would be remiss not showing this off to the this community, because if you do use IBM Cloud, it really does make some things significantly easier to use. And as you can see, we're playing around with some Vault stuff here in a moment, and I'll talk about that here in a second. But the beauty of this is that we now have a layer on top of IBM Cloud, in essence our cloud, that allows us to actually consume IBM Cloud how we need to. And there's no reason why we couldn't extend this to other clouds also, where in essence, if we needed to start spinning up clusters in AWS or Azure or whatever, it's all just API calls. So we could in essence use this exact same interface and then just change, create to whatever backend, and it does the work for us, which is pretty damn cool. So now, as you see that from the bash script moving over to AWX and this Kubernetes admin, now we've obfuscated away all of the changes we had to make by hand and then running it piecemeal. Now we have a unified application that we all can touch and work around. But the next step was actually taking it to the extreme, in my opinion, which is where we're actually going to automate the rest of the work. The cloud that we're creating is we have an internal GitHub infrastructure called github.ibm.com, and this is where we put in a request where you can just create a new issue, get started, and then fill out all this information. Now, the reason why this is important is because what we've done is we've actually we have a serverless job now that reads against the internal GitHub issues, and then creates and parses that information. So as you can see right here, this is that serverless app actually commenting back on this. As you can see here, these numbers are pretty damn close to the numbers from the create here a moment ago. And that's on purpose, because the ultimate goal is for us to be able to pull all this information out, specifically what we need to do, and then have this fill out all this stuff via the API. And I can just do like a /approve or whatever, i.e. here, and then I can just start spinning up the machines. So I don't even have to touch this thing anymore. So then all of a sudden, the actual interface that our consumers will be using is filling out the paperwork properly. We take a quick look at it, make sure that it's not something crazy, and then turn around and just /approve and have it create. It is good, in essence. What the coolest part about this whole portion of it is, it really is just a simple Python script that parses all the information through a couple tokens and then does some really basic checks against it. As you can see here, like we need to make sure that the name is shorter than 15 characters due to some of our restrictions on what we call grant cluster. Also, we've got to make sure that all our clusters are lower than 75, because if we have too many clusters being spun up, we have a possibility of overrunning. So there's a lot of really interesting opportunities here where we've just automated portions away to make things happen to what we need. So it's unbelievably powerful. So from a simple bash script to this application, we've now been able to, push all this thing through. Now, I do want to take a quick aside and mention that you probably noticed this API key, where we actually have to give the API key to IBM Cloud every time we do it. And that's one of the biggest challenges we have is the corporate policies. And I'll bring up the slides again here. Oops. One of the corporate policies is that the API keys that we have, they have to be under certain rules, because what you do with an API key on IBM Cloud is you truly go in as yourself. So if you have an API key and somebody can basically implement the same policies that you have, and that's problematic. So we've been looking at using something like HashiCorp Vault, and there is actually a HashiCorp Vault instance inside of IBM that we can actually take our application and run it internally. So then we can still talk to the IBM public API, but have everything, all the requests internal, which will make life much easier. But it's one of those moments where you run into corporate policy against, functionality, where we were taking down IBM Cloud, we were overrunning and sometimes not even getting the machines up and running in time. And now we actually have this robust system where we actually have a lot of pride and consistency on top of. where now we're running up against the corporate policies for specific rules and regulations, which is if you've never become a developer or don't understand development process, it's a very natural progression where you've gotten your MVP out. Hell, you've gotten farther than your MVP, and now you're running into the rules because the other situations happen. So it's worth mentioning. We also plan on building some type of scheduler around it, which turns out AWX actually has a scheduler built inside of it. So in theory, we could actually run AWX as our scheduler, but we might actually build our own due to the policies of API keys and whatnot. So it's one of those interesting situations where we started off with a simple bash script, tried to go down the typical configuration management path or Terraform path, and discovering that we could take portions of that world and leverage it to our advantage. And before we realized it, we actually had a fully working cloud that eventually will have the own interface all the way through up through GitHub. But the real question is, so was it really worth it? Was it really worth the time and effort that we've done to build this? And simply said, it was probably not. We've actually spent almost 3 years now trying to rebuild all this and go through all this. I've learned a ton, and my team has too. But like, it would have been just nicer to have an easier way to request, like, have this actual workflow built. There are some companies out there that do some really interesting things to teach courses around this kind of stuff, or like training companies and whatnot. But it seems like it's not really a fixed problem. Our fix is at least a way that works fine with IBM Cloud, but I know it wouldn't work with any of the major ones unless we tacked on those APIs underneath it through the Go app. So there's a lot of weird things around this, but we really did create a cloud on top of a cloud. And the ultimate goal is for us not to have to worry about it anymore, right? Like, I should be out on the road, or in this case, this video, speaking about these things and the lessons learned. So hopefully I can get to the point where the bots can do the work for us. So that's really it. Like, I just kind of wanted to walk through the natural progression that some companies have, or at least some projects have, where you start out with a really simple, like, let's just run a for loop to spin up 30 clusters. And before you know it, within a handful of, iterations, we've already gotten to the point where we have a whole open source application with leveraging upstream and downstream open source, to the point where we have a robust system where you put in some paperwork and you get a bunch of machines at the end. It's a really neat, like, situation. And I'm really proud about the work we've done as a team. And I really hope that we're going to do more. So if you ever have any questions or anything, please don't hesitate to reach out. Again, at JJ Asghar on Twitter, or awesome@ibm.com. And hell, maybe in a year's time, I might be somewhere completely different. But I can tell you from the team that we're working with now and what we're doing now, I'm really proud of what's going on. So that's really it. I hope y'all learned something, or at least saw that this is a path that some people go down. And also, sometimes using something upstream isn't always the right answer. Sometimes you have to build it yourself or take portions from it. And I hope you learned that. Thanks so much.